Greetings again everyone, welcome back to my channel. Here we have another algebraic exponential equation that we're going to solve. In this equation we have 3 to the power of x is equal to 3 times x. And we are given to find the value of x in this situation. Now you can pause this video and see if you can do this one by yourself. But I will share with you that these equations cannot be solved by using normal algebraic methods. For this exercise, we're going to use a special kind of function to solve for x. You may want to save this video for future reference, or you can subscribe to my channel for more math videos like these ones. You can also check out my Math Olympiad playlist to see how to solve other algebraic exponential equations. Now moving on to our solution, we said that we cannot use normal algebraic methods to solve this problem. And so the method that we're going to be using is a special kind of function called Lambert W function. This kind of function is used to solve problems where the unknown, which is the variable, is in the base and also in the exponent. Now how this function works is that if we have an expression such as a times e to the power of a, if we have this and we apply a w function to this expression, the result is a. So the key here is this expression here. We have a times e to the power of a. If we write our equation in the form of this expression here, then we can apply this w function. So from here we start by having 3 to the power of x, which equals 3 times x. We start by dividing both sides by 3 to the power of x. So on the left we have 3 to the power of x over 3 to the power of x. That's just going to give us 1 whole. So that means that from here we have 1 is equal to 3 times x over 3 to the power of x. And from here we can apply what we call laws of indices, where we have 1 over a is the same as saying a to the power of negative 1. So we can rewrite our equation in this form. So we say 1 is equal to 3 times x times 3 to the power of negative x. And now from here we continue to simplify our equation by dividing both sides by 3. In doing this we're going to be left with 1/3 is equal to 3x times 3 to the power of negative x over 3. The 3's can be cancelled out, so we're left with 1/3 is equal to x times 3 to the power of negative x. Now, as we are writing our equation in the form of a times e to the power of a, you'll notice that we have x here, and we also have times 3 to the power of, we have this negative x here. The problem here is that we have this negative right here. So we just need to correct this. So we need it right here with this x. So we're just going to multiply both sides by negative 1. And so from here, multiplying both sides by negative 1, we have negative 1/3 is equal to negative x times 3 to the power of negative x. So now we have negative x here, and we also have it in the exponent here. This means that in writing our expression as a times e to the power of a, we see that we have our 2 a's. But the problem is that we need this e, and we need it right here where this 3 is. So what we can do is that we can write 3 in terms of e. 3 in terms of e is equal to e to the power of ln of 3. The idea here is that ln is going to cancel out this e here, and so we're going to have 3. And to explain this theoretically, we know that ln means natural log, where e is the base of the log. So rewriting this, we have e to the power of log base e of 3. Now if we look, the base of the exponent is e, and the base of the log is also e. These cancel out, and we are left with 3. So what we're essentially saying here is that we can write 3 in terms of e by having e to the power of ln of 3. And so we can substitute our 3 into our equation as e to the power of ln of 3. So with this understanding, we can move on to writing our equation having the expression a times e to the power of a. So we have negative 1/3 is equal to negative x times e to the power of ln of 3. So we're just rewriting 3 in terms of e to the power of ln of 3. And of course, this is going to be raised to the power of negative x. So from here, we continue to solve our equation by rewriting what we have in the power here. So we have ln of 3 in brackets powered by negative x. Now our law of indices states that where we have a to the power of m in brackets powered by n is the same as saying a to the power of m times n. So we can rewrite our equation having this understanding just to simplify what we have here. So just to rewrite our equation, we have negative 1/3 is equal to negative x times e to the power of negative x times ln of 3. So in our exponent, we now have negative x times ln of 3. In writing our expression as a times e to the power of a, you can see that we have a little problem here. We have negative x times e to the power of negative x times ln of 3. To solve this issue, we need this ln of 3 here to be beside our negative x. We resolve our issue by multiplying both sides of this equation by ln of 3. So now we have negative ln of 3 of 1/3. And we are saying that this is equal to negative x ln of 3 as we are multiplying it times e to the power of negative x ln of 3. And now we can look at our equation. We are seeing that negative x ln of 3 times e to the power of negative x ln of 3. So we have a here, we have times e to the power of a. Now in understanding Lambert W function, having our expression a times e to the power of a, if we add a w function to this expression, our result is a. So what we're essentially saying here, if we were to take this expression and we'll take both sides of this equation, and if we were to have a w function on this expression, so we w both sides of this equation, it means that we can write our equation as follows. So we'll start right here. So we have w, and in brackets we're going to have negative ln of 3 over a third. So we're essentially saying that this is equal to what we have here. So we take the value of a here, so which is negative x ln of 3. So we're just going to take this and put it here. So our equation now is that we have w in brackets negative ln of 3 over a third is equal to negative x ln of 3. And now we start by solving x by dividing both sides of this equation by ln of 3. So in doing this, we know that ln of 3 is going to be cancelled out on the right. So just to rewrite our equation, we now have w of negative ln of 3 over a third all over ln of 3. And this is equal to negative x. And now to solve this expression that we have here on the left, we can use this calculating tool from Wolfram Alpha, and here plugging this into our calculator here, we get our value approximated. Now if you like this video so far and would like to see more of these kinds of videos, you can smash that like button and subscribe to my channel for my latest updates. So this value that we have on the left hand side of the equation, we said that that is approximated as negative 0.826. So writing this to 3 decimal places. And this is equal to negative x. To solve x, we now can divide both sides by negative 1. So from here we know that x is equal to 0.826 as our final solution. Now what we can do from here is that we can plug in this value of x into our original equation just to verify that this is correct. So our original equation is that we have 3 to the power of x is equal to 3 times x. Now since we find the value of x, we can therefore write this as 3 to the power of 0.826 is equal to 3 times 0.826. And what we can do from here is that we can use our scientific calculator to work out 3 to the power of 0.826. So we'll just go ahead and do that here. So in doing this to 3 decimal places, we get 2.478. Now let's times our solution by 3. So we have 3 times 0.826. And there you have it, we have 2.478. So this therefore proves that our solution for x is correct. X is equal to approximately 0.826. Now thanks again for staying tuned with me to the end of this video. I hope that this was very informative. If you would like to see more content like this, you can smash that like button and subscribe to my channel for the latest updates. And until then, I'll see you soon. Thanks again and take care.